Okay, now we'd like to look at a slightly more complicated problem where we have some fractions, and here we'd like to recall step one of more complicated equations from the lecture, one of the lectures before, and remember that if there are fractions on one or most sides of an equation, then one of the nice things to do, because you have an equation and you can do the same thing to both sides, is to multiply both sides by the LCD. So if we think, well, let's see, what is the LCD here? LCD of our equation here, because we have a 3 and a 2 in the denominator, would be 6. So that's what we'll do. We'll multiply both sides of the equation by 6. And going down here, so we originally have 1/3 times the quantity x plus 7 minus 1/2 times the quantity x plus 1 equals 4. So we'll multiply both sides by 6, and 6 times quantity 1/3 times the quantity x plus 7, close parenthesis, minus 1/2 times the quantity x plus 1, now closing the outside parenthesis where over here with the 6, and that equals 6 times 4. We've now multiplied both sides by 4. Now inside this parenthesis where the 6 is outside, we have actually two terms, and I've chosen this example so that we can really understand this well. We have these two terms. They're separated by the subtraction symbol right there, and so that 6 just distributes it into each of those terms. So in other words, we'll have a 6 times a 1/3 parenthesis times x plus 7 parenthesis minus 6 times 1/2 times the quantity x plus 1 equals 24. And we'll note again something here. Notice first that the 6 has distributed to each of the terms, as I was talking about before, and that now 6 times 1/3 will turn into 2, and 6 times 1/2 will turn into 3. And note one other idea here, that because we are actually multiplying each of these terms right here, here's one of them, because we are multiplying three things together, the 6, the 1/3, and the quantity x plus 7, then just as if you were multiplying 2 times 4 times 6, you just multiply the 2 times 4 and get 8, and then multiply times 6 and get 48. So here we're just going to multiply the 6 times the 1/3 and get 2 times the x plus 7, which is completely unaffected by that operation. It's just the third factor in the multiplication. Same thing happens in the next term. We get minus, and the 6 times 1/2 is 3, times the quantity x plus 1 equals 24. And so now we'll start with what we had with an earlier example. We'll distribute the 2 and distribute the 3. And so distributing the 2 first, we get 2x plus 14. And notice we have to be kind of careful here. This is a minus 3 we're distributing. It's like plus a negative 3. So we're distributing a negative 3. We'll get negative 3x minus 3 is equal to 24. And so now combining like terms on the left side, what do we get? We get minus x plus 11 equals 24. So now we'll subtract 11 from both sides. Minus x plus 11 minus 11 equals 24 minus 11. And so negative x equals 13. And again, we'll stop for a second and think, are we done? And the answer to that is no, really, because we don't have x all alone. That's always our goal. We want to know what is x. X equals something. And so at this point, then, we have to get rid of that negative, and we could think of it as dividing both sides by -1, or multiply both sides by -1, -1 times negative x. I need those parentheses there to make sure I don't mistake, especially the second term here. The second factor here of negative x for a subtraction sign is equal to -1 times 13. And so we do get down here the -1 times the negative x, that is x, and then we have x equals -13. Now again, we'll check. Let's check this. And so now we're going to start in our original equation and plug in for x. Every place that it occurs, we're going to plug in -13. So starting all the way back from the very beginning to make sure that I haven't made a mistake anywhere along the way, we'll say 1/3 times -13 plus 7 minus 1/2 times -13 plus 1. And what is that supposed to equal? That's supposed to equal 4, and we're checking that out. So we'll start by combining like terms inside both of the set of parentheses, and so we'll leave the 1/3 out here for now, and -13 plus 7, that's -6 minus 1/2 times, that'll be -12, -13 plus 1 equals 4. And so now we'll do each of those multiplications, because with this subtraction in the middle will come last. So that'll be -2 minus, what is 1/2 times -12? That's -6 equals 4. And that's -2 minus a negative is plus, of course, so plus 6 equals 4. And yes, we do get 4 equals 4. And that does check out, and we go back over here to the left side at the bottom, and we see, yes, x does equal -13. We'd like to take a look at our second example now, and this one is slightly different. We have actually a fraction on each side. Each of the coefficients on the variable y are fractions, and both of the constants are fractions. So as we did before, though, we'll just try to find the LCD of both sides. What would that LCD be? It would be 8 and 3, 6 and 4. The smallest number they both go into, all four of them go into, is 24. So we're going to multiply both sides of the equation by that 24. So 24 times this side times the 1/8 y plus 2/3, close parenthesis, equals 24 times the other side. Remember, we can always do that, multiply both sides by something that isn't 0. So 1/6y plus 3/4, close parenthesis. Now we'll distribute that 24 through. That'll be, that's 24 over 1, remember, so I can write that as 24/8 times y plus 24 times, distributing it through to the second term, it'll be 48/3 equals, well, 24 times 1/6 is 24/6 y plus 24 times 3, that's 24, 48, 72 over 4. So now, because we've chosen the LCD, or something that all four of the denominators evenly divided, then each of those fractions simplifies. Over here, to begin with, 24 over 8 is 3, so we have 3y plus 16 is equal to 4y plus, well, that be 4 goes into 72 18 times. So now we're down to a nice linear equation, all integers. So maybe we'll subtract 3y from both sides. 3y plus 16 minus 3y is equal to 4y plus 18 minus 3y. So simplifying that, we get 16 equals y plus 18. Finally, we'll subtract 18 from both sides. 16 minus 18 is equal to y plus 18 minus 18. So y equals, that'd be negative 2. So that's what we think our answer is. Again, we'll check over here. We'll plug in negative 2 in the two places y are in the original equation, two places that y is on both sides of the original equation. We get 1/8 times negative 2 plus 2/3 is supposed to equal, remember this is always is supposed to, that's a question mark, is supposed to equal 1/6 times negative 2 plus 3/4. So let's see, negative 2 times an 8, that would be negative 2/8 or negative 1/4 plus 2/3 is supposed to equal, what's that over on that side? That would be negative 2/6, which is negative 1/3 plus 3/4. Hey, and without, we could take LCDs and so forth, but think about adding 1/3 to both sides. If I added 1/3 to both sides, I get negative 1/4 plus 2/3 plus 1/3 is equal to negative 1/3 plus 3/4 plus 1/3. And so on the left side, we have negative 1/4 plus 1 equals 3/4. And adding 1/4 to both sides, I hope we can see we will get 1 equals 1. I could add 1/4 to the left side and a 1/4 is gone. Add a 1/4 to 3/4, I get 1. So yes, we did in fact, over here on the left side, we did find that in fact y equals negative 2 makes the equation a true statement, and so that is the solution.